Hi everyone, in this video I'm going to talk about special systems when we have infinite solutions and when there is no solution. So we're going to solve the system of linear equations y is equal to 2x plus 1 and y is equal to 2x minus 5. First by graphing and then second by substitution. So I'm going to graph y is equal to 2x plus 1 in blue, and then I'll graph y is equal to 2x minus 5 in pink. So for the y is equal to 2x plus 1, b, my y-intercept, is positive 1, and m, my slope, is 2, which is 2 over 1, we can think about. So I'm going to plot a point at 0, 1 for my y-intercept on my y-axis. And then I'm going to go up 2 and to the right 1, up 2 and to the right 1, up 2 and to the right 1. And I can also graph down 2 and to the left 1. Down and left are both negative. Negative divided by a negative is a positive, so it's just helping me plot it in the other direction. And I'm going to graph my line there. Then in pink, we've got y is equal to 2x minus 5. B, my y-intercept, is negative 5. So I'm going to plot 1, 2, 3, 4, 5, 0, negative 5. And my slope is also 2, so 2 over 1. I'll go up 2 and to the right 1, up 2 and to the right 1, up 2 and to the right 1, and conversely down 2 and to the left 1, down 2 and to the left 1. Okay, so the way that my lines are drawn, if I kept extending the pink line, kind of looks like eventually it would cross because my line is not perfectly straight and going through all of the points. But hopefully you notice as of right now, they're not going to touch and there's not an obvious, they're not obviously going towards each other. So here we have no solution because the lines do not intersect. And remember, when you solve a system of linear equations, the answer or the solution is their intersection point. And because these lines are parallel, the lines are not going to intersect, so there's no solution. If I want to solve by substitution, well, y is equal to 2x plus 1, and y is also equal to 2x minus 5. So because I have y equals and y equals, I can set 2x plus 1 equal to 2x minus 5. If I subtract 2x from both sides of my equal sign, well, then I end up with 1 is equal to negative 5, and that's never true, so no solution. Example 2, I'll do the same thing. I'll do this first one in blue and the second one in pink. Now the first one we have to rearrange slightly because it's not in y equals mx plus b form. It's not in slope-intercept form, so it's not super easy to graph right away. But I can take negative 2x plus y is equal to 3, and if I add 2x, add 2x, I've rearranged it, and now I can graph it more easily. I have a positive 2x plus 3. So I have a y-intercept at positive 3, and my slope is 2 again, or 2 over 1. So I'll go up 2 and to the right 1 a couple of times, or a few times rather, and down 2 and to the left 1, and graph that line. And for the pink equation, if I add 4x to both sides of my equal sign, I have 2y is equal to 4x plus 6, And if I divide everything by 2, y is equal to 2x plus 3. I have a y-intercept at 3, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1. And that line is going to sit right on top because they're both 2x plus 3. So even though the equations look a little bit different, negative 2x plus y is equal to 3, and negative 4x plus 2y equals 6, they're essentially the same line, so there are infinitely many solutions here because they cross infinitely many times. Now let's solve by elimination. So I'm going to take my original equations, negative 2x plus y is equal to 3, and negative 4x plus 2y is equal to 6. The top equation, I want to multiply by negative 2. When I do that, everything in blue, negative 2 times negative 2 is a positive 4x, negative 2y equals negative 6. When I add these together, negative 4x plus 4x cancels out. 0x. 2y plus negative 2y cancels out. 6 plus negative 6 cancels out. Well, 0 is always equal to 0, so there are infinitely many solutions.